Welcome! Today we're going to learn about integration and specifically the tangent function raised to an even power. So let's try an example. So in example number 1, we're going to integrate the tangent to the fourth power of x. So clearly we have tangent raised to an even power in this example. So the first step, or I should say step 2 in this example, what we're going to do is we are going to break it up or split up our function into powers of tangent squared. So since it's tangent to the fourth, it's simply going to be tangent squared squared, okay? And you can see then we can, break that up as to the integral of tangent squared of x times the tangent squared of x. Now, what are we going to do with this? Well, the reason we're using tangent squared is because tangent squared has a trig identity known as secant squared of x minus 1. And we are going to make that substitution. So if you look in item 3, or step 3, you will see that we have replaced our tangent squared with secant squared of x minus 1. Now, why are we doing this? The goal here is we're trying to set it up so that we can eventually have a u and a du all as part of our integral. And that's the plan. And since we know that tangent is, or I should say secant squared is the derivative of tangent, it makes sense to try to use that trig identity in a way that's going to help us eventually with this u substitution. So that's the plan. Okay, so let's move on to step 4. At this point, we're going to simply distribute our tangent squared, and we're going to multiply that. So we have tangent squared times secant squared minus, and then tangent squared times 1. We just simply distributed the tangent squared here. And then in item 5, we have basically split up our integral into two integrals. And you can do that so long the functions are either added or subtracted. You cannot do that if they're multiplied. So since we are subtracting tangent squared, that allows us to split up our function, or our integrals, I should say. Okay, so in item 1, we've just repeated what we already have. And now what do we do in item 2, in step 2? Well, the main thing here is if you look at C, where it says the integral of tangent squared, we're going to again make another substitution using that trig identity that we used before, secant squared minus 1, which we've done in D. If you look at D, we have replaced tangent squared with secant squared minus 1. All right, now what do we do next? In step 3, we're making quite a few substitutions here. Now, as I told you before, the key here is we were trying to match up tangent and secant squared together. And if you look at I, you'll see I have in that box, we've designated u as tangent of x and the du as secant squared of x dx. In other words, the derivative of tangent is secant squared, and we are going to utilize this when we make a substitution of u and du. So let's go ahead and do that. So let's go back to step 3, and you can see that if you go between steps 2 and 3, we started with a as tangent squared. Since we're designating u as tangent, that now becomes u squared in E. And as I told you earlier, the du is secant squared dx, which is what we have in B. So we replace that in F with simply du. Now we have an integral that's very simple. It's just u squared du. That's the whole concept here. We're trying to simplify our integral. Okay, now what about the rest of it? Well, in item D, we have an integral, but there's a minus sign. So that allows us to break that up into two integrals. And we do that in G and in H. We've broken that integral in D into two separate integrals. Alrighty, now let's see what happens. And just to, if you're wondering how the plus came about, we had subtracted a negative number, so that's where the plus arrives. Okay, so let's now move on to step 4. Now we're set to integrate. We're in a position where the integration is fairly straightforward. The integral in step 3, where we have u squared du, well, that's just general power rule. So that becomes u cubed over 3. Then when we integrate the integral in g, well, the integral of secant squared is tangent. So we do that. And the integral in h, well, the integral of dx is just x. And of course we have to add a c because this is an indefinite integral, so we always add a constant. And the final step is to substitute back where anything that has a u in it, we must substitute back because we want our final answer to be in terms of x, not in terms of u. So u was designated as tangent of x, which we have in item I. You can see we had designated u as that. So we're going to replace u now with tangent, and since it was u cubed, it's now tangent cubed over 3. And in step 5, that is our final answer, and we are done. And that is integration of the tangent function raised to an even power. Now go practice, practice, and practice some more.